for inviting us to the Battery Tuesday. Thanking the I also want to thank the audience for taking 1 hour out of your schedule to call in and see what or learn what Imerys Graphite and Carbon can offer for the lithium-ion battery industry. Okay, with that, I would do a quick introduction of the Imerys Group, then talk about Imerys Graphite and Carbon, conductive additives for lithium-ion batteries, development trends that we see in the market, and finally, sustainability aspects. The whole thing should take about 35-40 minutes so that we have some time for questions at the end. Introduction into Imerys. Imerys is a French minerals group. The headquarters is in Paris. We basically operate mines across the globe. We offer different minerals to very different markets. Minerals like mica, quartz, talc, feldspar, calcium carbonate, going into very, very different applications. One of the important assets for us is the quality of the mines that we operate, best-in-class operations. Understanding customer applications, so we sell our minerals into very, very different markets. That can be construction, that can be polymers, automotive industry, mobility applications, very, 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 very different applications. You will learn a bit more. What is important for doing all this, also considering the portfolio that we have in terms of minerals, is customer application knowledge. So across the globe, as Imerys, we operate what we call Imerys Technology Centers that serve customers also with application data to allow them to use our minerals and put them into their products to get the best benefit out of that. What's very important as well is the last bullet point here that you see on the left side. As we are a company that is operating mines, we need to run the company in a very responsible way. This is absolutely necessary to get the acceptance and support of the countries and the communities where we have operations. A couple of numbers. Globally, 24,000 customers, operations in 39 countries. And again, when I say operations, it's mainly mines and processing plants that we operate. We have 13,700 employees across the globe. Last year, our revenue was 3.8 billion and EBITDA number was 630 million. This year, we target 670 million. That was just confirmed during the Q3 call last week, where we updated the markets on our business progress. In 50% of our businesses, we claim to be the number one. We have sales in about 126 countries. And the sales split you see down here, most important market for us, Europe, followed by the Americas. And this is mainly North America and then Asia, and in Asia, mainly China. Minerals per se is not a very attractive business. So minerals is nothing that gets investors excited. So what is it that we focus on to grow the business? Of course, we want to get our minerals into fast-growing markets. And here we identified a couple of areas where we intensify our activities. And this is also a very good transition towards Imerys Graphite and Carbon. So one of our business areas is called Solutions for the Energy Transition. A big part of that business area is Imerys Graphite and Carbon business. Here we sell graphite and carbon black into the mobility applications markets, mainly EVs. But we also sell high performance minerals into that market. It's not graphite and carbon business, performance minerals business. Basically talc going into polymers that are being used for making lightweight parts for cars, and a joint venture that we operate, the Quartz Corporation, where we provide a high purity quartz to the industry that's being used to make crucibles that are then being used to make high purity silicon. So that's supporting solar industry, that's supporting semicon industry. And again, the value here is really the high purity quartz that we provide so that our customers can use those materials to make high purity silicon. Sustainable construction, very, very big topic. You may know that the global construction and concrete industry is responsible for a large chunk of the global CO2 emissions. So anything that we can provide to lower CO2 emissions in that business has real value. And here again, we talk about additives that are being added to concrete to make it less CO2 intense. Natural solutions for consumer goods. Here, mainly the topic is to replace polymer solutions that exist today in the market with mineral solutions. We also talk about circular minerals here. So the idea of using minerals is that if possible, you also recycle them. So you're not constantly depleting resources and mines, but wherever possible, you also recycle your minerals and feed them back into the product loop. And finally, and you may have heard about that as well, lithium. This is a more recent project. We call it Emily. It's an evaluation of a lithium-rich mica deposit in France, where we have the plan to produce lithium salts, lithium hydroxide mainly, but it could also be lithium carbonate, that are being used for cathode materials in lithium-ion batteries. We also have a joint venture with British Lithium. And as it's stated here, second bullet point, clearly this is targeting the lithium-ion battery industry. If fully operational, that mine would be able to supply lithium good enough for about 700,000 electric cars per year, and it would mainly target the European market, of course. Now going to Imerys Graphite and Carbon, those are the numbers and some data for Imerys Graphite and Carbon. Again, the Imerys Group revenue. At Imerys Graphite and Carbon, we operate 3 R&D labs. 20% of our revenue comes from new products and new solutions. That's also driven a lot by applications like mobile energy, lithium-ion battery, fuel cells, where we constantly launch new products. And most of our solutions are highly customized, which is good for us, of course. We operate 4 industrial sites. The one here in Switzerland, in Bodio, where we make synthetic graphite, and you will learn more about that later, is IATF certified, very important for our automotive customers. It goes all the way down to raw materials. Of course, we are ISO certified, strong customer focus, and as Imerys Graphite and Carbon, we subscribe to and support responsible leadership principles. We're a world leader in graphite and carbons. It goes back all the way to 1908, where the plant here in Switzerland in Bodio was established. It was initially a silicon-carbide plant that had graphite as a byproduct. And then over the years, markets turned, and today it's a synthetic graphite plant where silicon carbide is a byproduct. We are a unique supplier of 4 carbon materials, so we have not yet seen a company with a similar product footprint in the market. We offer primary synthetic graphite, processed natural graphite. We don't operate mines. We don't operate natural graphite mines. We buy natural graphite and we process it. We offer carbon black, conductive carbon black, and silicon carbide. If you look at our global footprint, we start in Switzerland, in Bironico, in Ticino. This is where we have our headquarter and our main R&D hub. So we operate an R&D facility here, 3,000 square meter. We have an R&D facility in Toulouse where we mainly do polymer application research, so conductive polymers, thermally, electrically conductive polymers. And we have a lab in Japan, this metro area, Tokyo and Kawasaki, where we do lithium-ion battery research, where we make coin cells and pouch cells to evaluate our conductive additives in those applications. We have sales offices all over the globe, in North America, in Europe, and then in China, Korea, and Japan. I talked about the R&D labs and industrial sites. For Bodio, Switzerland, this is where we make our synthetic graphite. In Willebroek in Belgium, we make conductive carbon black. In Terrebonne in Canada, we have a plant for the processing of natural graphite. And in Japan, in Kitakyushu, in the southern part of Japan, we operate a facility which allows us to do conductive coatings on our carbon materials, so provide additional functionalities for different applications. For us as a business, and this is primarily driven by customers here in Europe, and that's probably not news for you. The markets that we serve in Europe over the last years, there are more and more questions regarding LCA data. What are we doing to reduce our CO2 footprint? And here we listed a couple of items where we are actively working on or that we have succeeded in implementing over the last years. Sourcing of clean energy. Our plant in Bodio gets the electricity, of course, from the Swiss grid, almost 70% being renewable. Here, purchasing hydropower, this is what we do in Canada, in Willebroek in Belgium. Part of the carbon black process is that we have an off gas, and this off gas is now being used together with E.ON, a utility company from Germany, to power a energy recovery unit that's basically taking that off gas and then is burning it and turn it into electricity. With that, we're able to reduce greenhouse gas emissions, as you can see here, by 70 to 80%. And for our headquarters here in Veronico, we run completely on renewable electricity. We have solar cells on our roof, and what we need to buy from the grid comes from hydropower. Now, looking at our technologies, at Graphite and Carbon, we only deal with one element in the periodic table, and that's carbon, but carbon comes in very different forms and crystallinities. So we look at natural graphite, primary synthetic graphite, conductive carbon black. The difference here is simply the crystallinity, the structure, the shape, the morphology of the particles. Highly crystalline materials like graphite, more amorphous and structured materials like conductive carbon black. What we sell at the end are powders and dispersions. So we're not selling any hardware pieces, we're selling powders in different particle size distribution, different particle size, smaller fractions, larger fractions, different functionalities, dispersions, water-based dispersions. We don't touch organic solvents. So today what we sell in terms of dispersions are water-based dispersions. And that goes then into very, very different applications. And you have more on the next slides, but what our customers are looking at are electrical and thermal conductivity. That's mostly what our customers are interested in. Of course, graphite and carbon black offer way more. They provide other additional advantages, lubricity for synthetic graphite, chemical inertness, high temperature stability, low weight, good mechanical resistance, and there's more and more. But mainly what our customers are interested in is conductivity, and it's either electrical conductivity or thermal. If we go into our main end markets, it's automotive, energy, and consumer electronics. We are the market leader for conductive carbon black and graphite in lithium-ion batteries. And there's one caveat, and then I will explain that in a minute. The graphite that we're selling is not an active anode material, it's a conductive additive, and I will explain that. Graphite in alkaline batteries here as well, it's a conductive additive. Graphite for carbon brushes and conductive carbon black in conductive polymers. And that goes into medical applications, that goes into trays for semiconductor chips. The purpose always is that you want to avoid to build up static charges, and that's where those things are being used. But it also goes into power cables driven by electric mobility and more charging stations. So this is what we support with our products. Application areas, 4 major application areas for us: mobile energy, polymers, engineering materials, metallurgy. So on the right-hand side, those are very traditional application areas. Those application areas we serve since many, many decades. Some of those applications shrink, they go away, others grow, others stay stable. But the big growth that we see today is mainly in mobile energy and in polymers. And in mobile energy, it's mainly driven by lithium-ion batteries, but also other applications like fuel cells. Again, those are the R&D facilities. I mentioned it earlier. Toulouse, France, polymer application, Switzerland, here in Veronico, We have 11 different labs: product development, process technology, analytics, dispersion lab. We have a dedicated lab to work on nanomaterials on the highest safety standard, so that's separated from the rest of the a lab has its own HVAC cycle so that we can work with nanomaterials that are not yet fully understood, and our battery application lab in Japan. Now, going to conductive additives for lithium-ion batteries, and here I want to come back to synthetic graphite. You all know how a typical lithium-ion battery is designed and built. So you have a cathode where you have mixed metal oxides or iron phosphates as an active material that hosts the lithium ions. On the anode side, you have graphite as an active anode material, but this is not what we do. What we provide are conductive additives that go into both, into anode and into cathode, to basically facilitate and improve lithium ion transfer and electron transfer and travel. As you know, the lithium ions, when you charge the battery, travel from the cathode through the electrolyte to the anode, are being intercalated into active anode materials. And for doing that efficiently and repeatedly reversible, you need to have good conductive additives. Good conductive additives are being used on both sides. They go into cathode and anode. On the cathode, it's mainly carbon black that's being used as a conductive additive. We see new developments today.
Oops,
Yes.
We have lost you for some seconds, but it's good to have you back. All good.
What was the last thing you heard?
Yeah, I cannot say the word, but it was possibly something like 10 seconds, so not
okay.
long. Don't worry.
Okay. So the important thing is that our materials are being used on both sides at a weight percentage of 1 to 5%. It's always conductive additives, but it's very essential for the performance of lithium-ion batteries. And here you see that again, you have a cross section of a lithium-ion battery on the left side, cathode, separator, anode. On the cathode side, we talked about the active materials. You have in the cathode, of course, also a binder and a conductive additive. It's mainly carbon black today, but you can also use carbon nanotubes, CNT, graphene, or graphite. Material costs, as our material is an additive, it only makes a small fraction of the overall bill of materials on the cathode and on the anode side, which is good for us. The carbon black is mainly done in our, or is only done in our plant in Belgium. And what you see here on the right-hand side is a bit of a weight split that gives you an idea of how much kg of those materials go into a 50 kilowatt hour cell. And you see for carbon additive 50 kilowatt hour cell, depending on the amount of carbon black that you add to your cathode formulation, it's 2 to 6 kg, but not more, right? For the other elements, it's significantly. We don't do anything on the separator side, and then on the anode, similar to what you see on the cathode, active material here is graphite. It's a spheroidized graphite or a synthetic graphite that is very isotropic. Our material, again, you will see that is an anisotropic material. It doesn't work as active material, but it is an excellent conductive additive. Binder, conductive additive here, it's mainly our graphite, carbon black, but also CNT. Especially when you come to anode formulations that are being used today, where you have a higher silicon content being used to increase the capacity on the anode side. Our synthetic graphite is made in Switzerland, and here as well for the same 50 kilowatt hour cell. On the right hand side, you get a bit of an idea of how much is being used. Those are the main products. On this slide, I would like to introduce the main products that we sell today into that market. As we discussed before, it's synthetic graphite and carbon black. And you see electron microscope images here on the right. Top is a typical synthetic graphite, SFG 6L. SFG is a special type of graphite that we make. We make different types of synthetic graphite. SFG is a graphite with a very high degree of crystallinity. L indicates that this has a high purity design for the lithium-ion battery market, and the number 6 indicates the D90 of those high aspect ratio particles, which is, of course, a bit of a theoretical value. If you look at the SEM image here, you see that the synthetic graphite is very high aspect ratio graphite, so very thin, flaky particles, and it's very anisotropic, our material, but it works very well as a conductive additive, being used at 2 or 3% or 4% in the anode formulation. Carbon black, you see a transmission electron microscope image here at the bottom. C65T, Super PLI, those are our blockbusters that we're selling since many years into the lithium-ion battery market. Actually, as a predecessor of Super PLI was used in the first commercial lithium-ion batteries coming out of Japan in the 90s for mobile devices. Today, those materials are being sold, especially C65T, for lithium-ion batteries for EVs. This is a very different material, as you can see here. Look at the scale, it's 200 nanometers. So the primary particle size here is between 20 to 40 nanometers, depending on what type of carbon black we look at. And those primary particles are agglomerated, grown together. And what you want is a highly structured, three-dimensional carbon black particle, because that's what provides conductivity. Basically, those pathways that you see here for carbon black, those are the pathways for lithium ions or electrons to travel in the anode and cathode. The higher the structure, the smaller the primary particles, the better the conductivity of this material, and the less you need to use in a cathode or anode formulation. So they can be used on their own or combined. This is one of the things that we offer to customers, that basically when they come to us, they can get a tailored carbon black plus a synthetic graphite to really optimize performance in the electrode. We sell it as powders, but we also sell dispersions with carbon black and synthetic graphite for current collector coatings. It's important for LFP batteries, but also for new technologies like dry electrodes. And we can, of course, make pre-dispersions of carbon black also with nanomaterials, carbon nanotubes. You see again the list of products here: SFG, different particle sizes, KS, it's another synthetic graphite that's being used in the industry. It's very often that with one customer, one product works well, with another customer, another product works well. It depends on the active materials, it depends on the electrode design, it depends on the target of the battery. Is it an energy battery or a power battery? So all of that plays a role. At the end, we have a portfolio that can address a wide range of requirements on the customer side. And our best-selling carbon black, Super PLI and C65T, they have a relatively high BET. Difference between both is purity levels, and I will talk about that later as well. When it comes to synthetic graphite, you see a picture of our plant here in Bodio. When you come to Ticino, when you leave the Gotthard tunnel, you travel another 30 kilometers south. Then on the left-hand side, you will see, and it's a very narrow valley, but you will see blue roofs, and that's our synthetic graphite plant. Highly crystalline materials, highly conductive. It's actually an active additive because, of course, it has a reversible capacity at low rates. So we sell it as an active conductive additive. And it also offers things like thermal conductivity, which is important, especially for applications where you charge and discharge your battery at higher rates. And if you follow the industry, especially for EVs, one of the things that lithium-ion battery companies are targeting are faster charge rates to allow you to quickly fill up your battery to continue travel on a highway. And the faster you charge, of course, the more thermal energy is being released, and to get that out of the battery, we have data showing that our high aspect ratio synthetic graphite helps you with keeping your cells at a comfortable temperature. The higher the temperature, the more side reactions you have, and which will impact negatively cycle life and at the end, ultimately also safety. So the material coming out of Bodio, very high crystallinity. Because of the specific process that we apply, high temperature process, close to 3000 C, we achieve very, very high purities. Basically, the temperature that we apply drives out impurity. We end up with very, very high purity materials where we have single-digit ppm levels of impurities, and that's also what the market needs and is asking for. Very low metallic magnetic particle content. We don't have to do any washing or any purification. The way it comes out of the process, of course, we mill it down, we condition it, we fraction it. We have different fractions. We may do a surface modification, but then we can sell. We don't have to have a chemical purification step. The same is true for our carbon black. Here again, it's years of experience that allows us, that's not years, it's decades of experience that allows us to make a high purity conductive carbon black. That's a picture of our plant in Willebroek in Belgium. Unique combination of high structure and surface, low surface area. That's why Super PLI C65T are most sold conductive carbon blacks in the lithium-ion battery industry. Good electrical chemical performance at low loadings. This is what you are looking for. You don't want to add a lot of your conductive additives. You would like to have good performance at low loadings. And this is also very important. We see a lot of competition, especially in China today, trying to target our materials. The big challenge for all of those companies is to establish a reliable production where you constantly, at a 10,000 ton per year scale on a line, produce conductive carbon black, consistent quality, high purity. This requires a lot of experience. You cannot simply build a plant and hope that the product that comes out is good enough for lithium-ion batteries. Same what I said before applies to carbon black. We don't have to have a chemical purification process. So the way we operate our plant, the way we make carbon black delivers a high purity product so that no further purification, chemical purification is required. Now, going into development trends for conductive carbon black. I mentioned that before. What customers are looking at or looking for is high conductivity at low loadings, low addition rates. And you can achieve better conductivity by increasing the surface area of your conductive carbon black. You see here another grade that we sell, Super C45, Super C65T. Those are products you can buy from us today. And by the end of this year, we will launch what we call a Super C130 and a Super C600. The name indicates the surface area, specific surface area in square meter per gram. The higher you go in surface area, the better the conductivity is. So for instance, for a Super C600, you only need to add half of what you need to add for a Super C65T to get the same conductivity in the cathode. And of course, that is value to customers because they can add 0.5% more active material, which allows them to go to a higher energy density. Purity remains almost unchanged, so higher BET carbon black will be available at similar purity levels as our standard carbon blacks today. Processability, and that is simply a result of the higher surface area, decreases. And everyone who has dealt with materials with high surface area, this is a very known challenge. The higher the surface area, the more difficult it is to handle those materials and get them into a matrix where they should be used, right? So viscosity goes up as soon as you add a high BET material to a typical cathode slurry. So you need to work with the surface chemistry as well to provide a product to customers that they can easily use and process in their applications. Next generation conductive additives, carbon nanotubes. This is quite interesting. Until 5 years ago, you have not seen that in lithium-ion batteries. Today, carbon nanotubes are widely used, especially in China, as conductive additives on the cathode as well as on the electrode side. The big players for CNTs are today in China. At an earlier stage in my career, I was working for Bayer Material Science in Germany. And back in 2005, 2006, Bayer was leading when it came to carbon nanotubes. They developed those materials as conductive additives for their polymers, polycarbonate, polyurethane. And in 2009, they had the biggest production plant at 200 metric ton per year facility for CNTs, but this all went away. So today you don't find a big CNT maker outside of Asia anymore, and the biggest ones are in China. CNTs, why are they attractive? You see that here on the right-hand side in the electron microscope image. You basically can consider them as wires that connect the particles in the cathode or in the anode, and with that, of course, provide excellent pathways for electrons. So when it comes to electrical conductivity, nothing is better than carbon nanotubes. And the smaller the diameter of the carbon nanotubes, going all the way to single wall, the higher the conductivity. They have a very high aspect ratio here as well. The higher the aspect ratio, the more functionality they can provide in theory. But of course, it's very, very difficult to process them and get them then into a matrix. So you always need to work with slurries. You provide basically dispersions to the customer so that they are not forced to deal with dispersion issues that come with the CNT themselves. So you need to provide them something they can use right away. The other point that's a bit of a challenge for CNTs. CNTs are being made by using a metal oxide as a catalyst. So in the product, you have metal oxide fragments, metal oxide pieces coming from the catalyst. Depending on where the CNTs are being used, it may not be acceptable for customers to live with those impurities. So that requires then an acid washing. And again, this technology today only exists in China, where carbon nanotubes are being washed in acid solutions to provide higher purity CNT products to customers. We work on solutions where we combine carbon black with CNT. Why? Because we think, and we also have data that show that, and it's not just us, you also see that published in literature, that there is a synergistic effect. When it comes to carbon black, you have good electronic conductivity, but carbon black, amorphous conductive carbon black, is very, very good at lithium-ion conductivity, where CNTs are not good. You have good processability, you have the quantities available, it's a lower cost material, you have industrial scale production available, and if you combine that with CNTs, you basically get a conductive additive. Again, if you combine that, you work with a dispersion, in which you have carbon black and CNT, and this allows you to basically tailor the performance of your conductive additives. Are you a customer who looks for a better cost proposition, or are you performance oriented, and that determines how much CNTs and carbon black you use in such a blend. Low quantities are needed, and as I said, you can basically optimize it according to your needs. Now going to the last topic, and I see that I'm okay in time. Sustainability aspects, and this is driven mainly by customers in Europe. Today, our lithium-ion battery business is 90% in Asia, China, Korea, Japan. Most of those customers there, to be clear, they are not interested in sustainability aspects. Today, the whole market is driven by costs, so you need to be able, also from a cost point of view, to be competitive, even if your product performs better. You don't have a chance in that market in Asia today if you have a good performing product, but you are not able cost-wise to compete with what is available elsewhere. Sustainability aspects, topics driven by customers here in Europe. new players in the market, companies like PowerCo, ACC, Northvolt, Verkor. All of them are very much looking for data that show that you are able to provide a sustainable product and that you also have roadmaps in place to lower your greenhouse gas emissions um, um, over the years going forward. So for us as Imerys Graphite Carbon, we reduce greenhouse gas emissions by 20%. We have require our suppliers to have an EcoVadis rating, 68%. IGC suppliers engaged to have climate science-based targets, 42%. Of course, we want to get those numbers up. 84% of our product portfolio has been assessed according to sustainability criteria, and this is very important as it pertains to R&D. We follow at Imerys a approach that's called sustain agility. So for each new product development project that we start within Imerys, not just Imerys Graphite Carbon, but within Imerys, we do a sustain agility rating. So together with our corporate sustainability experts, we apply a certain process to evaluate the sustainability aspects of the product. And unless it's neutral or positive, we don't even start to work on a new product development. So we want to have it neutral or positive, else we would stop a new product development. I showed earlier what we do when it comes to our production sites, where we source green electricity, where we install energy recovery units to lower the CO2 footprint of our production facilities. The next step, and this is a very important high priority topic for us as R&D, is also to look at more sustainable feedstocks. Today, both our synthetic graphite as well as our carbon black, they rely on fossil feed-based feedstocks. They come out, and you see that here on the right-hand side, they come out of a typical oil refining value chain. Here as well, it's not just a fashion choice that we look for sustainable feedstocks. It's also clear that this whole value chain will change in the next years. And with that, some of the feedstocks that we use today may not even be available in 20 or 30 years anymore. So we need to look for alternatives. One of them, of course, being biomass that comes in different forms. And we do that already today. And this is also the approach that we will follow going forward. You can plug them in at different points in the value chain. So at the end, we will not switch from a fossil feed-based fuel to a completely renewable fuel within days, but we will add, for instance, 5, 10, 20, 30% of renewable oils to our feedstock, or renewable or sustainable coke-like materials for our synthetic graphite process. Another aspect that we're looking at is recycled feedstocks. And it's not just lithium-ion batteries. You have two examples here for lithium-ion batteries where you look at recycling of graphite. But there's more out there. You can, and other companies are doing that. It's not necessarily conductive carbon black, but from automotive tires, recycling of automotive tires, you end up with a pyrolysis oil, you end up with steel, and you end up with a significant amount of carbon black. And the question is, how can you reuse that? Again, this is not the carbon black you use as a conductive carbon black, but it may be a feedstock for our processes going forward. So we look at different graphite, at different carbon sources that are available today, and how we can use them to make our products more sustainable going forward. And that brings us to my last slide. So we are making carbon and graphite since 110 years. We are part of the lithium-ion battery industry since the 1990s. And over time, the business was growing. Initially, only consumer electronics, and now, since a couple of years, with the EVs, or with EVs being more and more popular, we see a strong increase in demand. important for that industry is that you are able to provide products of high quality and consistency. You need to be able to provide customized solutions because, of course, customers want to have or want to differentiate their products. We work with customers together, so collaboration is something that's very, very important to us. Innovation, continued innovation through an R&D team and excellent facilities that we have. Here again, when it comes to Imerys, the financial strength and the size of the company clearly helps us to grow with the market. If you need to double capacity within 2 or 3 years, it's very, very helpful to be part of a larger company to have the money available to execute those investments. Continuous improvement, corporate social responsibility, sustainability, those are aspects that are simply part and need to be part of our business and become more and more important going forward. And with that, I'm at the end of my presentation. Thank you very much.
Well, thank you very much, Frank, for these interesting insights about these important materials for making lithium-ion batteries. So next time when I'm leaving the Gotthard tunnel, I will actually have a look to the blue roofs in Bodio. Yes, yeah. Usually, I have to say that this what is it, Tensol or whatever, this big factory, Tensol rail, this big factory, distracts my eyes when I pass there. So, but next time I will certainly have a look. Well, I think the questions are open now. Please raise your hands if you have questions to Frank. We still have some minutes to discuss. What I find interesting, you mentioned that the carbon nanotube industry completely left Europe. Can you say 2, 3 words about that? Is that because there is really no market anymore, or is it because of safety, or?
I think it's a story that you've seen over and over again, that Europe is very, very good in starting something, but then at a certain point lacks the stamina and the long breath that you need to move such new product developments into applications. So you stop, and then those things are being scooped up elsewhere in the world when the time is right, and then scaled very, very quickly. Yeah. And with carbon nanotubes, I think Bayer was very early. They did not succeed to get that into polymers and get those polymers sold to customers. I think at that point in time, yeah, maybe the time was simply not right. And then 20 years or 15 years later, it's a blockbuster conductive additive in China. Yeah.
Mm-hmm. Mm-hmm. But how, I mean, you somehow mentioned it a bit, but I think, yeah, you try a bit a different approach with Imerys. How do you overcome those challenges? Because now also in the battery world, they're certainly there, right? So what's your experience?
Yes. So I think in the battery world, and you see that, and some players do that in a very, very smart way. I think at some point, especially also as a European player, if you want to stay relevant and successful, you need to partner. You need to partner with players. You need to make smart investments. You may need to form joint ventures. If you look at, for instance, LG Energy Solutions, how they partner with different car companies across the world. I think those are models that you need in the industry to stay relevant, because it helps you, of course, to lower the risk for yourself. And you also, you can bring together, if you find the right synergies, different strengths to offer something to the market that is relevant and that customers are buying. Yeah. So I think it's a bit, you cannot rely on your own ability to innovate. You need to partner. You need to partner with customers. You need to partner with other players in the market.
Mm-hmm. Well, thanks for that insight. Again, now to the audience here, Please raise your hands or ask questions in the chat directly to Frank. That's still open. And well, if not, then I would suggest that to thanks you once more for the presentation of today.